Okay, so today we're really going to get into some probability notation and kind of get the overview of how you kind of look at these events and think about these events. So here's the main thing for today. I want to start out with just going through what all of these things mean. So I have this Venn diagram over here with a probability of A and a probability of B, and you can see that there's overlap. Maybe there's some overlap, maybe it's zero, and then some maybe some probability out here, we don't know for sure. So you always try to box around these Venn diagrams because this is the entire sample space and these are your events that you could happen. Let's just look at this first one. This first one, when it says P parentheses A, is saying this is the probability of A, which the probability of A would just be this right here. So this is just the probability of A. So generally you just circle that entire circle. It includes this overlap, like everything in this circle is this. So if this was, let's say, 0.1 and this was 0.2, the probability of A would be 0.3. It includes this entire circle even with the overlap. This is an AND symbol. And you can probably try to remember that. It's really called an intersection, so the intersection between the two. But it looks like an N, I think, so that's how I remember it was AND. So in our case that we just made, that'd be 0.2 for our AND symbol. And then we have the probability of A or B. So the probability of A or B, so this is my OR symbol. Let's just put a probability of B in here. Let's say it is, I don't know, 0.2 again. If you were going to do the probability of A or B, that would be this circle and this circle combined. So when we count that up, that'd be 1, 3, 5. So that down here, that U shape is an OR symbol. And in this case right here, it was 0.5. And when I think about this for a second, if this is 0.5, this out here would be also 0.5 because every single probability set that you have has to add up to 100%. So if this circle is 50%, this has to be 50%. If this was 70%, this would have to be 30. It always has to become 100%. You'll never have more than 100%, and you'll never have less than 100% in the entire sample space. Now we get over to these, and you can see that I did some slashes for these because these mean all the same thing. It means not A. So this means not, this little symbol means not, and this symbol means not. Like all these things mean not. So this is not A. When I look at this for not A, it would include everything that is not an A. So that would be this little bit, because that's not an A, and this little bit, which is not an A. So it's 0.7. One thing you should notice is that A and not A add up to be 100%. And that should make sense because, like, if you have one thing and you have the opposite of the other thing, that should make up everything. Like, there's no way that something is not A or A, but it's like neither. Like, it has to be one. It's either A or it's not A. So it has to add up to 100. Same thing if we did the sample set of B. Like if you look at B, the probability of B is 0.4. The probability of not B is 0.6. So these, like probability of A and the probability, let me zoom out a little bit. Whoops, I kind of made that small. Let's just do it over here. The probability of A plus the probability of not A should always equal 1. Okay? So when you think about that, just try to keep that in mind when you're doing all the problems. Or I'm going to try a couple problems that are on today's math-based assignment, and we'll see if we can kind of get them started. Okay, so they give us this Venn diagram, and we have a whole bunch of missing parts. So let's see if we can fill in all these things. So they say there's 23 kids, 12 play basketball, 5 play football, or 13 play football, and 5 play both. Anytime I see this, I'm going to put like the 5 in the middle here to make it easy on myself so I can think about the both. Now, a lot of people are just tempted to put 12 here. They'd put 12. But that's not right, because then if you look, how many kids play basketball? Well, 12 and 5 is 17. Oh, we only have 12 kids that play basketball. So when you're looking at this, this is the total number. So this is this entire circle. So we need this entire circle to be 12. Well, if we have 5 already, this would have to be 7. Now let's do the other one. So there's 13 people that play football. Again, that's this entire circle. So if 5 play football already, that would mean that we'd have 8. Because 8 plus 5 would give me 13. Now we had a total of 23 kids. So if we had a total of 23 kids, that means all of this should add up to be 23. And we'll say 7 plus 5 plus 8 is 20. So we're short. You're like, oh, so if we're short, that means what we're short should be the extra kids that don't play either football, that don't play either football or basketball. So 3 kids don't play either of these sports. Let's try to do a whole bunch of probabilities. Okay, so let's find the probability of A. Well, the probability of A is 12 over the total, so 12 over 23. Let's find the probability of not A. So the probability of not A would be, well, this is an A, this is an A, so 11 over 23. You could also do the opposite. Again, these two things should add up to be 1. Let's do the probability of A and B. The probability of A and B would be 5 over 23. Let's do the probability of A or B. The probability of A or B would be 7 plus 5 plus 8 over 23, which we already added those together, and that was 20. Let's do the probability of A and not B. Well, the probability of A and not B would be, this one's a little bit trickier, so you have to look and find where this intersection happens at. So this circle is A, but this is B, so A and not B would be this 7 right here, so that'd be 7 over 23. Let's do the probability that it is not A or it's not B. So again, this is a little bit tricky, but you just go to each thing and you just ask yourself, does it fit the requirement? So this 7, does it fit the requirement? Yes, because it's not B. Success. This one, does that 5 fit the requirement? No, because that 5 is A and B, so it doesn't fit the requirement to be not A or not B. 8, does it fit the requirement? Yes, because it's not A. 3, does it fit the requirement? Yeah, because it's not A and it's not B. So this one would be all those numbers besides 5, so that'd be 18 over 23. And let's do one more. So let's do the probability of, oh, I don't know, not A and not B. Well, the only things that is not A and not B is that 3, so that'd be 3 over 23. Okay. So as you kind of go through this and do the different things, they can ask you a lot of probability questions, but the basic idea is try to figure out what it's asking for and think about where it is on the Venn diagram. We're going to do one more where I set up a Venn diagram from this kind of information. Okay, so suppose we have this problem right here, and it gave us all this information. The first thing that I do when I get information like this is I try to convert these nots to like the actual. So this is like not A. So I know A would have to be the opposite, which would be 0.6. And I know B would be the opposite again, which would be 0.3. So now we have those kind of ideas. So then when I'm setting up my Venn diagram, I draw my circles. I know that this, let's call this one A and this one B. I know that this circle here would have to be 0.6. And I know this entire circle here would have to be 0.3. Now we can't assume that there is no overlap. And it wouldn't make sense for there to be overlap because they said A or B would be 0.7. So this entire thing would equal 0.7. Well, if you look at this whole thing equals 0.9, but they said the two circles together equaled 0.7. So if you think about what that means in context, this is too much by 0.2. So that is the overlap. The extra amount that we're actually overcounting by counting these circles twice is 0.2. So that is what belongs in the middle. And if that's 0.2, if this whole thing is 0.6, this would be 0.4. And if this whole thing is 0.3, this would be 0.1. And then at the end, I always count it up to make sure I did it right. Well, 0.4 plus 0.2 plus 0.1 would give me 0.7. So we've set it up right. And if you do the other part, this is 0.6 and this is 0.3. So it matches all of the things that we needed it to match. Then you go, how much is out here? Well, if this whole thing is 0.7, we need it to add up to 100. So there's our 0.3. So that is our Venn diagram. And we can then use our Venn diagram to answer any questions. There's one more little tiny piece of information that's helpful. If there's ever overlap, this is a normal event. But if your overlap is ever 0, that has a special name. So if we had a Venn diagram, and the Venn diagram did this, and you were like, oh, this is 0.7, and this is 0.2, and this was 0.1 out here, so this has no overlap. If something has no overlap, it's called mutually exclusive. So you just look to see if it has overlap. If it has overlap, it's not mutually exclusive. If it has no overlap, then it is, meaning that these two events don't intersect at any point. Like they can't both happen at the same time. So try the different events today. If you need help, just let me know. I know this was a longer video, but I tried to include a lot of information in it. So feel free when you're watching any videos to skip ahead if you need to, or go back and rewind.